Welcome to our notes on evaluating functions. So to begin, we need to remember a few vocabulary words. I mentioned them in the last lesson, but input was what we put into the function. Now, when we have functions, we usually put inputs into x, because x represents the input slot. And the outputs is the answer we get out. So what we get out. And usually we represent that with y. So for example, if my equation is y equals 3x minus 4, I could ask you the question, what is the output if the input is 5? Well, I want to know what the output is, meaning what is y, if the input x is 5. So I'm just going to rewrite this question. What is y if x is 5? So that's basically saying the same thing. So what we do is where we see the x, instead of x, I'm going to put a parentheses. So I just copied everything the exact same. But instead of x, I put a parentheses there. And it's telling me x is 5, because the input is 5. So instead of x, I'm going to input into that parentheses 5. So now, y is 3 times 5, which is 15. And I bring down the minus 4, and 15 minus 4 is 11. So the answer is if the input is 5, the output is 11. Alright, so what we did this on is something called a linear equation, because if we graphed it, it'd make a straight line. However, there's other types of equations out there in math, and so I'm going to show you some of the advanced equations. There's a lot more, but these are some of the few basic ones that we start introducing in this class. So linear equations, you just multiply and subtract, and it's going to create a linear line. However, this equation has, you see the two lines on either side? They look like ones on each side of the x. It means absolute value. So it looks like that when we say the absolute value of x. The absolute value of x. So technically, this is what the absolute value does. Oh, Maxine, no kitty. Okay, so technically what the absolute value does is it counts how far away something is from 0, right? So explaining that, 3, how far away is 3 from 0? Well, 1, 2, 3. But what about negative 3? Negative 3 is also only 3 away from 0, so the absolute value of negative 3 is also positive 3. So really what absolute value does is it makes it positive. So for example, the absolute value of negative 2, well, how far away from 0 is negative 2? The answer is 2. So it makes it positive. However, if it's a positive in there, the answer is still positive, because it's just how far away it is from 0. So then we have this one, an x with a little tiny 2 in the upper right hand corner. And we read it by saying x squared. And here's what x squared means. An exponent, this little 2, tells you to times x to itself twice. So what it does is whatever x is, you times it to itself. So it's x times x. For example, if x was 4 and it's being squared, that means 4 times 4, which is 16. The next one is, when we look at it, it's an x with a little tiny 3 in the upper right hand corner, which means it's also an exponent, just like this 2 is for squared. And when it's a 3, the words we say is x cubed. And what it means is you're timesing x to itself 3 times. So x times x times x. So for example, if it was 4 cubed, so 4 with a little exponent of 3 up there, what that means is you do 4 times 4, which is 16, times 4 again, which ends up actually being a total of 64. So, in math, when you're working with this stuff, it's important to remember the order of operations. Some of you have learned PEMDAS for order of operations, and some of you have learned GEMS. And GEMS is technically the better one, but I'm going to quickly remind you what they are. So in PEMDAS, what comes first is P for parentheses. But it doesn't just mean parentheses. It means any sort of grouping. So that's why G is better for grouping, because grouping could be parentheses. It could also be the absolute value sign. It could also be any of your exponents, like x squared or x cubed, just like the ones I just showed you. We could put brackets around it. There's a lot of things for grouping. So you do any of these first. What I mean by grouping is that if there's things in them, you make sure it's just one number. And we'll get there and I'll explain that more. But the next thing we do is exponents. So E is for exponent. An exponent is both the parts of PEMDAS and GEMS. It's just the second thing you do is always exponents. Remember, exponents were like that x squared thing, right? That's where you actually apply that little squared. Now next in PEMDAS is multiplication. However, it's misleading because it doesn't just mean multiplication, it also means division. Because multiplication is division. Dividing by 3 is just multiplying by 1 over 3, like the fraction 1/3. So multiplying and division are really the same thing. So it's M for multiply and D for divide. But in GEMS, they just use the M because multiplying is dividing. So they expect you to know that. And really, it's not like one comes first. You just do whichever one you see first because you read math left to right. And so it's like whatever one comes first in the equation is the one you do first. Same thing with adding and subtracting. Subtracting a number, like 5 minus 3, is the same thing as 5 plus negative 3. Because subtracting is just adding a negative. So AS stands for adding and subtracting. But again, they're the same thing, so it's not like adding comes before subtracting. They're on the same level. So it's whichever one comes first. Which in GEMS, they just put an S. Well, they use the S over the A because it makes the word GEMS, and the A wouldn't make a word. But the S just stands for subtracting or adding. So let's turn the page over. So this is where we're going to evaluate functions. At the top, you see it says, let's say f of x is 3x minus 2, and j of x is 5x squared minus 1, and m of x is x cubed plus 3, and z of x is the absolute value of x minus 4 plus 5. So if I said plug in 3, you wouldn't know which one I'm talking about. However, when I have a bunch of them listed there, they all have different names. This one's called F, this one's called J, this one's called M, and the last one's called Z. So when it says, what does f of 3 mean? That means wherever x is, because it usually says f of x, right? And x is the input slot. Well here, when it's f of 3, and the 3's inside the parentheses, what that means is you take the function f, so f okay, So my camera died partway through and I didn't notice, so all this writing has now appeared. So I'm going to go back to where the last video ended and explain everything I've written down so far. So it started with what does f of 3 mean? So what I do is I rewrite f of 3 and it equals 3, and then you put a parentheses, close your parentheses, minus 2. And the reason why there's a 3 in here where x was is because of this 3 here. So this is a question telling you take the function f and plug in 3. So take the function f, plug in 3. Took the function f, which was 3x minus 2, but instead of x I plugged in 3. So 3 times 3 becomes 9. I set the minus to 2, and that's 7. So my answer is that f of 3 is 7. Then there's a different type of question I can ask you, which says, what does x equal? So find x if f of x equals 28. And basically what that means is it's saying the function equals 28. Remember f of x just meant y, right? So it's saying y equals 28. And remember earlier I said y was output. So what this is saying is that the output is 28. Or that the whole thing, 3x minus 2, equals 28. So instead of f of x, because it equaled 28, I wrote 28 here, where f of x was up here. And the equation was 3x minus 2. So to solve for x, I have to add the 2, because I get rid of the thing being added or subtracted first. I have to do it to both sides. So 28 plus 2 is the 30. And then on the right side, I only had 3x left, because the 2's canceled. Then I had to divide both sides by 3. And 30 divided by 3 is 10. And 3x divided by 3 is just the one x. And so x equals 10. My answer in words is if my output's 28, because it equaled 28, then the input is 10. Because the x I found, which x is input, would have been 10. So if I plugged in 10 into my equation and did 3 times 10, that would be 30 minus 2, that is 28. And so, moving on past that, we have some more examples. For example, I said find j of negative 2. So what I did was I took j, that's why it's underlined, and j is 5x squared minus 1. So instead of x, I put a negative 2. 5, parentheses, negative 2 being squared. Not the x, but negative 2, because that's what we're plugging in now. Minus 1. Well, negative 2 squared means negative 2 times negative 2. So I saw the 5 in front. And it's being timesed to negative 2 times negative 2, and then close my parentheses, minus 1. Well, now for the next step, I recopied my 5. And negative 2 times negative 2 is positive 4, because a negative times a negative is positive, and 2 times 2 is 4. And I still have minus 1. Well, 5 times 4 is 20, minus 1 is 19. So my answer in words is if my input is negative 2, my output, because the answer I got out, is 19. Okay. The next one says find m of 2. So I take m, which is this guy here, x cubed plus 3. And instead of x, I put a parentheses and I cube it plus 3. And instead in my parentheses, I'm going to put the 2 that it's telling me to put there instead of x. So now 2 cubed means 2 times 2 times 2, and then I'm going to add 3. So 2 times 2 is 4, times 2 again is 8. Plus 3 is 11. So for m, if my input is 2, because that's what I put into x, my output is 11, because that's the answer I got out. It also would have been my y if we were using y instead of f of x. The next example says z of negative 3. That means I take z, which says it equals the absolute value. Instead of x, I'm going to put a parentheses, minus 4, in my absolute value, and then add 5. So in that parentheses is going to go this negative 3. Well, when you see a parenthesis, you usually think multiply, but there's no number in front to multiply by. And so it's not negative 3 times negative 4. If it was negative 4, it would be in its own parentheses too. What it is just negative 3 minus 4. Because it was x minus 4. And x is negative 3. So negative 3 minus 4. So I'm going to rewrite it without the parenthesis because it really just means negative 3 minus 4. The parenthesis matters mostly if there's a number in front of the x because that means you times them together. But it's like an invisible 1. And so like 1 times negative 3 is just negative 3. And then I add my 5. Well, remember which comes first in order of operations is grouping. And we have a grouping because in the absolute value are two different numbers. And we need to put them together, group them together to make them 1 first. So negative 3 minus 4. You owe me 3, you owe me 4. You're going to, all together, owe me 7. Then you add 5 at the end, and I had to close my absolute value, because the absolute value is still around that negative 7. Now remember, absolute value means how far away are you from 0, or it just makes it positive, because negative 7 is 7 spaces away from 0. So it just becomes 7, and now the absolute value could go away, because we took it, we did the absolute value. And so once we've done it, it goes away. And then we add 5. And 7 plus 5 is 12. So the answer, in words, is if my input is negative 3, my output is 12. Now the next 3 are very different because they don't say plug in a number, because there's not a number in the parenthesis. They say find x if f of x equals negative 8. Well, I take f of x then, which is 3x minus 2, and I make it equal negative 8. And I solve for x. So the first thing I have to do is get rid of the thing with x that's not being multiplied to it. So 3 is being multiplied, so not that, but the other thing, the minus 2. I get rid of minusing 2 by adding it. So I still have 3x, but negative 2 plus 2 became 0. And then on the right side it says equal negative 8 plus 2, which is negative 6. So I'm going to divide both sides by my 3 to get x alone, and x then is negative 2. So this time we word it backwards because what they gave us wasn't what we put in. What they gave us was the answer, the negative 8. And we had to figure out what went in. So what we say is if my output is negative 8, then my input is negative 2. So this one says find x if f of x equals 0. So I'm going to take the 3x minus 2, set it equal to 0, because it's saying f of x is equaling 0. Draw on my wall, add the 2 still, same steps. Still have 3x's, the minus 2 plus 2 went away. Over here, 0 plus 2 is 2. I then need to divide both sides by 3. So that I get x equaling, you can't do 2 divided by 3, you'd get a decimal. So we can just leave it as a fraction. We can just say it's 2 over 3. So my answer in words is if my output, because they gave us the output first, is 0, then my input is 2/3. And finally, and the last one on this page says f of x equals 13. So we take the f of x function, which was 3x minus 2, and we make it equal 13. We draw our line. We add 2 to both sides. So that 3x equals 15. Divide both sides by the 3 in front of x. So that x is 5, because 15 divided by 3 is 5. So my answer in words is if my output, because they gave me the y first, is 13, then my input is 5. Alright, so we've talked about how to do these with equations, but remember in math we have equations, tables, and graphs. So, go to the next page. We'll talk about how to do this on a table. Alright, so once again my camera died. I'm having a lot of technical issues today. And I can't find a pencil, so I can't erase anything that I've already written on this. So I'm just going to have to explain to you everything that happened. So basically, on a table, we need to talk about how to do the same process of evaluating a function. So on a table, remember what this means is at one point when I plug in -2, the function, whatever it does, the answer it gave me was -3 because y is the answer. So side by side is like a pair and they're together. So when it says what is h of 0, remember if it's in the parenthesis like this, it means it's x. So I look at x and find where h is 0. Oh, it's right there. And that's where x is 0. And the answer, the y, the output, is -2. So that's why we wrote -2. But that's different from the next one that says what is x when h of x equals 0. Because if it's equaling 0, that means it's the output, which means that's the y. So I look, where is y 0? Oh, it's right here, so I drew an arrow to show you. That's where 0 is. So the x for that was 4. So it's when x equals 4, do you get an answer of 0. The next one says what is h of -2? That means when x is -2, what is y? Well, you can see that when x was -2, y was -3. And then it says what is x when h of x equals -2? Well, if it's equaling -2, that makes it the y, and that's right here. And the x was 0, so it's when x is 0. Well, now we have to talk about it on a graph. So remember, on a graph, the x's go left and right, x's, and the y's go up and down. So it's saying what is s of 2? So I look on my graph, because remember, if it's in the parentheses, that means it's the x. So where is x2? That's right here. And I go up and touch my graph. And look, the answer says it tiny above it, that it's 53. That's the y. It's just because there'd be too many tick marks, and it would look all bad if they tick marked it. They just put the number right above it. But it means the y is 53. So here, when x was 2, the y was 53. However, what is x when s of x is 59? So I look where I get 59. Oh, it's right here. What was the x right here? 5. So when x is 5, it goes to 59. Now the next one said what is x of 6? So I find where 6 is on my x's, because in the parentheses means x. And I look up, and it goes all the way up to 67. So the answer is 67. However, when it says what is x, when s of x equals 43, that 43 is the output, meaning the y. I find where it equals 43, oh, it's this first one, so on day 1. So it's when x is 1. And that's how you do it on a graph.